All right, guys, we're on the last section of chapter 6, section 6, systems of inequalities. So before we graphed and solved linear inequalities. Now we're going to solve systems of linear inequalities by graphing and apply systems of linear inequalities. So one thing we also did was we solved and graphed systems of equations. Well, we're going to do a similar thing with linear inequalities here. So that's the new vocab, is system of inequalities. So Jackal is beginning an exercise program that involves an intense cardiovascular workout. Her trainer recommends that for a person her age, her heart rate should stay within the following range as she exercises. It should be higher than 102 beats per minute and should not exceed 174 beats per minute. So here's the beats per minute. So it should be less than 174, so below, if you could imagine a line here, but above 102 minutes right here or above. Okay. The graph shows the maximum and minimum target heart rate for people ages 0 to 30 as they exercise. If the preferred range is in light green, so in here, how old do you think Jackie is? So here's how this thing is working. So as your age increases, your minimum heart rate goes down, and you want it to be above that minimum, so up here. Okay? But you also want it to be below a maximum heart rate. So your heart has to, you don't want to be beating too slow or you'll be sluggish or dead, and you don't want to be beating too fast or you'll overwork it and maybe have a heart attack. Okay, so you want it to be in this sweet spot, which is in the green area. So if they say her heart rate should be between 102 and 174, 102 is like right about here, and 174 is right about here. So if it's in this range right here, then I would say she's about 15 years old. All right. So the graph above is a graph of two inequalities. A set of two or more inequalities with the same variable is called a system of inequalities. So how this is a system of inequalities, this one above, is this line right here. If we had the equation for that line, it'd be less than or equal to that line and shade everything below. Then if you had the inequality for this line, you'd graph the equation of that line and shade everything above it. Then the sweet spot is the ranges of heart rates. All right, pretty cool stuff. The solution, though, this is important, of a system of inequalities with two variables is the set of ordered pairs that satisfies all the inequalities in the system. So remember when we solved, when we graphed linear inequalities, any point that landed in the solution region, in the shaded part, was a solution to that inequality. Well, with systems, you have the points that are solutions are points that work in both shaded regions at the same time. So the solution set is represented by the overlap or the intersection of the graphs of the inequalities. So when you do these, you're looking for the overlapping region, and all the points that are in the overlapping region are the solutions. So for example, if we graphed this line right here, if we knew the equation for it, and the shaded part we would find out would be everything above that line, like up here. Okay? Then if we graph the other blue line, we'd find out that you have to shade everything below it. So everything down here. Well, you could see that the part that overlaps is right in green, and that is the solution region for that system. Okay, so let's try some. So let's solve the system of inequalities by graphing. All right, here's some graph papers. So this one is already in slope-intercept form. So I graph the equation y equals negative 2x plus 1. So y-intercept of 1, and then the slope's negative 2. So negative 2 as a fraction would be negative 2 over 1. So that just means I go down 2 over 1. And then I do it a couple more times to see how the line should go. Right, and notice the inequality is strictly greater than. So when I put my line on here, I'm going to do a dashed line like this. Okay, then I could test the point 0, 0. If I put 0, 0 into this inequality, you would get 0 is greater than 1, which is false. which means the origin, 0.00, is not included in the shaded region, so I would shade this side. All right, now let's do the other equation. It's y equals, or I would graph the line y equals x plus 3. Well, you go up here at 3, 1, 2, 3, put your line, and then the slope is understood to be 1, so you would go up 1 over 1, up 1 over 1, so forth and so on. And then you could go in the opposite direction like this. Okay? And since it's less than or equal to, you would fill it in with a solid line like this. Okay? Then you test a point. Try 0, 0. Is 0 less than or equal to 0 plus 3? Or so is 0 less than or equal to 3? Yes. So I'm going to do it in a different color. You would shade the side that contains the origin, like that. Now the overlapping region, I'm going to do it in green, is this part over here where it's doubly shaded, you could think of it. So that would be the solution region right there. Okay? So when you're doing these, if you have to do any of them by hand, you want to like totally shade in that region, okay, and make it stand out so that I know, or whoever's grading it knows, that that is the solution region, okay? And make sure your lines, you can tell that the lines are dotted or solid lines for yours as well. Okay, so the graph of y equals 2x, negative 2x plus 1 is dashed and is not included in the graph of the solution. The graph of y equals x plus 3 is solid and is included in the graph of the solution. So the solution of the system is the set of ordered pairs in the intersection of those two graphs, or in other words, I like to call it the overlapping region. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. Now, I'm not going to do all of these, but I wanted to show you a couple things. So 1a, y is less than or equal to 3. You would just put a line up here at 3. Okay, and if I plugged in the origin, you plug in 0, 0. Well, there's only an x value or only a y value, so 0 is less than 3. So it's everything below like this. Okay. Then the other one, x plus y equals 1. I would use intercepts. So when x is 0, y is 1, and when y is 0, x is 1. So you have intercepts right here and here. And since it's greater than or equal to, you'd fill it in with a solid line like this. And then test the origin. Is 0 plus 0 greater than 1? No. So you'd shade the other side like that. And then the overlapping region is kind of this triangle right here. Okay? So I would do the other ones similarly. Now, 1b, I would use intercepts to graph those because it's pretty straightforward if you plug in 0 for x and 0 for y. This one I would solve and get it in slope-intercept form because when you solve for the intercepts, it's not going to be as easy. These two, I would use intercepts to graph those ones as well. Okay? All right. So sometimes the regions never intersect. When this happens, there is no solution because there are no points in common. So let's look at an example. If I solve this system, 3x minus y is greater than or equal to 2, and 3x minus y is less than negative 5, here's what you get. I would do the line 3x minus y equals 2, and then so you have negative y equals negative 3x plus 2. I'm just subtracting 3 from both sides. Then divide everything by negative 1. So you get y equals 3x minus 2. Basically just solving it for slope-intercept form. So the y-intercept's negative 2. Come down here, negative 2. And then up 3 over 1. Up 3 over 1. Now it would be a solid line. And let's see, does the origin work? If I plug in 0, 0, you get 0 is greater than or equal to 2, which is false, so I shade the other side. Okay. Now the other equation is 3x minus y is less than negative 5, so I do 3x minus y equals negative 5. Subtract 3x, so you get negative y equals negative 3x minus 5. and then divide everything by -1, and you get y equals 3x plus 5. So you go up 5, 1, 2, 3, 4, 5, put a point, and then your slope would be up 3 over 1, or you could go down 3 back 1, down 3 back 1, and you would have a dashed line there. Plug in the origin. Is 0 minus 0 less than -5? No, it is not. 0 is greater than all the negatives, so you shade there. And since the lines have the same slope, they both have a slope of 3, these lines are never going to intersect. And since you're shading to the right of this line and to the left of this line, the regions never overlap, and the answer is no solutions. So in this case, you would have to say that. You would have to say, since the two graphs are parallel and the regions never overlap, the lines never intersect, there is no solution to this system. Okay? So there we go. Here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So this first one here, if I graphed it, you would have y is greater than 3. So you go up 3, put a dashed line at 3, and shade above. This one is less than 1. Y is less than 1, so you put a dashed line at 1, shade below. The regions do not overlap, and therefore you would not have an overlapping region. Therefore, there is no solution to that one. All right? All right, stay tuned for the next video.